All right, let's jump right in. Today, we're tracing an absolutely incredible survival story, your own evolutionary story, actually. In this explainer, we're going to do a high-quality, simple, but surprisingly detailed breakdown of exactly how mammals evolved, piece by piece.
I mean, just think about the sheer scale of evolutionary recycling happening inside your own head right now. It's wild. The tiny bones allowing you to hear my voice, yeah, they were literally used by your ancient ancestors to chew their food. No way, right? But to understand how we got our ears, along with our warm blood, our fur, and, the ability to produce milk, we really have to go way, way back.
So, here's our roadmap. We're going to follow this lineage through 6 major evolutionary upgrades. We've got the deep roots of the mammals, upgrading the body plan, repurposing jaws into ears, the origins of milk, thriving under the dinosaurs, and finally, surviving the asteroid. We'll break down how all these defining traits of modern mammals were pieced together, often, honestly, one global crisis at a time.
Okay, let's start with Section 1, Deep Roots of the Mammals. Over 300 million years, this takes us to a world way before the first dinosaur even hatched. So, this epic journey actually kicks off over 300 million years ago, back in the Carboniferous period. That really set the stage for everything. Around 320 million years ago, our specific lineage split off. By 299 million years ago, a group called the Therapsids basically ran the world. They were the dominant land animals. Now, they took a massive hit during the Permian mass extinction, but this tough, resilient group called the synodonts somehow survived the apocalypse 250 million years ago. And it's from those lucky survivors that, around 225 million years ago, the first true mammalia forms finally appeared.
Now, here's a super important point. Our ancestors were never reptiles. Never. We belong to this synapsid lineage. You might have heard the historical term mammal-like reptiles, but actually, scratch that, it's totally outdated. We split from the sauropsids, which is the group that would eventually become modern reptiles, dinosaurs, and birds, taking a completely different, honestly fascinating evolutionary path. Which brings us to Section 2, Upgrading the Body Plan, Triassic Transformations. As the Earth shifted from the Permian into the Triassic period, our ancestors had to undergo some serious anatomical upgrades just to survive.
Early amniotes had this lizard-like sprawling posture and really uniform peg-like teeth. But then, the therapsids changed the game. Moving their limbs directly underneath their body mass allowed for way faster running and a much more efficient gait. And, at the exact same time, their teeth started to differentiate into specialized tools. We're talking incisors for nipping, canines for tearing, and molars for shearing. Basically, they unlocked powerful new ways to process food, which meant one big thing: more energy.
And man, did they need that energy. Because about 233 million years ago, right in the late Triassic, one of the greatest upgrades in the history of life happened. I'm talking about endothermy, or warm-bloodedness. This wasn't just, a simple temperature shift. It completely revolutionized the mammalian body plan. To keep all that new heat in, insulating fur and hair evolved. Plus, warmer blood could power much larger, way more complex brains. It allowed for faster reproduction rates, too. And perhaps most importantly, it gave our ancestors the ability to operate in the cold and hunt at night. They carved out this totally nocturnal niche that kept them safe from the emerging, daytime hunting early dinosaurs.
All right, Section 3, Repurposing Jaws into Ears, a complex upgrade. This is, hands down, one of the most mechanically complex adaptations in our entire history. It's basically nature's ultimate recycling project. Over millions of years, the main jawbone, the dentary, enlarged so it could support those powerful new chewing muscles we just talked about. And as it got bigger, the smaller bones at the back of the jaw, which used to form the jaw hinge, well, they weren't needed for chewing anymore. So they shrank, they loosened up, and eventually they completely detached from the jaw. These tiny, repurposed bones became the malleus and incus, the hammer and anvil of your middle ear. They just happened to be perfectly sized to process airborne sound frequencies.
But evolution is a really gradual process. Take the cynodont Thrinaxodon, living 250 million years ago. Biomechanical analysis of its fossils actually shows it was already capable of tympanic hearing using a soft tissue eardrum. This means these early precursors were already tuning in to the high-frequency sounds of the Triassic world, listening out for predators and prey in the pitch dark way before they were technically true mammals. Which leads us to Section 4, the origins of milk, a defining trait. What about the feature that literally gives mammals our name? How did milk evolve?
Well, we can use the modern platypus as a window into the past to see how early lactation likely worked. Picture a simple mammary patch on the skin. Early on, ancestral apocrine glands likely secreted moisture just to keep their parchment-like leathery eggs from drying out. These secretions just oozed directly onto the fur, no nipple required. Hatchlings would lap up this moisture, and over millions of years, this fluid became more and more enriched with nutrients, eventually evolving into what we know as milk.
And this changed literally everything about how we reproduce. Because milk became this incredibly rich source of nutrition outside the egg, early mammals could weigh much smaller eggs. This resulted in the birth of tiny, highly dependent babies. These early mammals actually possessed epicubic bones jutting forward from their pelvis, likely to help support the weight of these tiny, helpless babies as they suckled in a pouch, kind of like a modern marsupial. Okay, so we've built the basic modern mammal, but in Section 5, Thriving Under the Dinosaurs, Mesozoic Diversity, we really need to bust a major myth about their time during the Mesozoic era. See, the old story was that mammals just cowered in the shadows, waiting for the dinosaurs to die so they could finally do something interesting. Not true at all. During the Jurassic and Cretaceous periods, mammals were incredibly diverse. You had Castorocata living a semi-aquatic, beaver-like lifestyle. You had Volaticotherium with skin flops gliding through the trees like a flying squirrel. And Rapenimammus, that guy grew large enough to actually hunt and eat juvenile dinosaurs. Mammals were already filling so many diverse ecological niches. And one of their absolute secret weapons for that success was the tribosphenic molar. Picture the upper tooth acting like a pestle, crushing down into the basin, or mortar, of the lower tooth. It is an absolute evolutionary masterpiece. It combines shearing, crushing, and grinding in a single bite. This built-in food processor allowed our ancestors to eat a vastly wider range of foods, from insects to plants to meat, which fueled their spread all across the globe. This brings us to the dramatic conclusion of our explainer in Section 6, Surviving the Asteroid, the KPG extinction, the cataclysmic event that changed the world 66 million years ago. We all know the story. The asteroid wiped out the non-avian dinosaurs. But contrary to the popular idea that dinosaurs were just completely holding mammals back from evolving, recent research tells a much more nuanced story. New fossil and genetic models, specifically things called total evidence tip-dated trees, show us that mammalian radiation and physical evolution were actually already well underway before the asteroid even hit. The extinction event had a way more complex effect on us than just opening up empty space. So, it leaves us with this really fascinating puzzle to ponder about your own 300-million-year-old origins. If we were already building our toolkit, the warm blood, the intricate ears, the milk, the versatile teeth, and we were diversifying long before the sky literally fell, are mammals just destined to inherit the Earth through brilliant, unstoppable adaptation? Or are we, when it all comes down to it, just the luckiest survivors of the apocalypse? Definitely something to think about next time you hear a sound or take a bite of food.